Financial fraud doesn't leave a single smoking gun. It hides across multiple data streams, transactions, logins, risk alerts, that individually look perfectly normal, but together reveal coordinated attacks. That's why researchers propose the multi-stream fraud transformer. Instead of flattening everything into one timeline, it runs independent transformer encoders on each stream. Each event gets a time-aware positional encoding based on actual timestamps, so the model understands that 3 failed logins within an hour is fundamentally different from 3 over a week. Then comes the fusion. They tested 5 strategies, but the real breakthrough is cross-stream attention paired with a gated fusion mechanism. The gate is a lightweight MLP that computes soft importance weights across the full multi-stream context. Mathematically, it normalizes these weights and collapses the representation back to the base dimension, acting as a built-in regularizer that forces the model to commit to a single weighted combination, rather than relying on a k times expanded feature space. This lets the architecture dynamically route account takeover signals to the login encoder and card fraud signals to the transaction encoder. The results are stark. On a 10 million user dataset, these sequence models hit a 0.99 AUROC, which measures ranking discrimination, completely obliterating the 0.74 baseline of gradient-boosted trees operating on aggregated features. A single-stream baseline with the exact same parameter budget drops 18 points in AUROC, proving that per-stream inductive bias isn't optional, it's mandatory. Gated fusion specifically pushes precision to 0.989, which is critical for production systems where false positives freeze legitimate accounts. Validated on real banking data, this architecture delivers a 22% relative AUROC improvement. It's a clean demonstration of why explicit multi-stream temporal reasoning will replace static feature engineering in modern fraud detection. If you want to dive into the full ablation study and architecture diagrams, check the link in the description.